have already seen this picture. So just going over it one more time. The client serves on the behalf of the user, and it can read from data nodes or write to the data nodes. In order to get to any of the blocks of the data nodes, it has to contact the master node first because it contains the information of where all these blocks are. And once it gets that, it can contact the individual data nodes and perform any of the read, write, or other operations on the blocks. And inside the rack, there could be a number of data nodes. As we mentioned, those are connected together through network switch, so it's Ethernet connection, and that is connected to the master switch that connects all of these racks together through a faster network. So this is very similar to a regular file system. In a regular file system, you have roots directory, and then there is directories underneath, and then there is more directories, and then you have files on the bottom. This is very similar. The only difference is that this happens on a single hard drive, and now we have all of these connected to other hard drives through this master node on the top. So it is a hierarchical system because the directories are nested into one another and the files are in the bottom. We can create, so each of these directories has information of what files it has inside of it and what subdirectories are underneath. And also it contains the metadata about the file attributes, the size of the file, the name of the file, who created the file, and all this information. So meta information, any changes that were done to the files, so these data nodes will send all this information to the master node that is responsible for keeping all this metadata and where the pieces of each file are located. And where are all the copies of each block. So the file has the number of blocks. We already mentioned that. If it is too big, if it's not that big, it might fit into a single block. But since we're talking about large data here, usually the file ends up broken into a number of blocks. Okay, so the blocks are replicated 3 times as we mentioned. We can configure that. We can replicate it more than that if we want to. And there is also the heartbeat that goes from the data node to the main node, master node, to show that data nodes are alive. We have a choice of where we're gonna put all the copies of a single block, and where we put them makes a difference, because if we have to search for them in very far away places, and that may take a long time because we have a network that we have to go through, and so we need to make some decisions where to place those copies to optimize the performance. So optimizing the copies or the replica placement is something that makes this HDFS system distinguished from other distributed systems. So the goal is to improve reliability and the network, and to utilize the network bandwidth that we have in an efficient way. That is not an easy subject. That is just pretty much a research question. Right now, the only thing we do is we place one copy on the local data node and another copy on another rack, and the third copy on the same another rack that the second copy is, and the rest of it is just placed by random. So if you're interested in that subject, or how to optimize that, then we can look at some research papers, or someone wants to work on that for their study report, it's also a good idea. We mentioned that the name node stores the metadata, so and it keeps a log of every time anything is done to any of the files or the blocks of the files. So if any files are created or deleted or updated, who accessed them, at what time they accessed them, all that is stored in a log. And the namespace, including the mapping of blocks to files and their properties, is stored in that name node in certain files called the file system image. So this master name node keeps image of the entire file system and a map of where the blocks are in memory. They're saying that 4 gigabytes of RAM is sufficient to support this kind of structures. So when the master node is started up, it gets this file system image and logs from its local file system and updates them with the new information. So with the log that there have been any changes, and stores a copy of the file system image at its local disk. So we mentioned that this name node, if it fails, we either keep a backup or we have one more node that can replace it. Because if this one fails, pretty much we lose the information for the entire file system for the entire cluster. Data node or the servant node on the other system, it has no knowledge about the entire system. It only has knowledge about itself and what files it has on its local drive. With HDFS, we are using a special algorithm to decide the best number of files that we should store in a single directory. on these data nodes. So the number of files that it stores is not random, but we use some algorithm to try to determine what's the best number of files that it can store.